Hi, my name is Andy Sappi from OnPoint Digital Solutions, and today I'm going to talk about a new method of regional methane leak detection. The technology that we've been developing is called passive optical heterodyne spectroscopy. It's also known as laser heterodyne radiometry. It's a lot like LiDAR, except that the light source that we're measuring is incoherent. It's not a laser. In this case, we just use the sun, but it can be used to measure flames in incandescent lamps and other incoherent sources. And like LiDAR, it confers standoff detection capabilities. So you can actually look at something that's happening far away and detect the presence of, say, a gas leak. It provides very large aerial coverage, and the instrument itself is shown in the lower right-hand corner here. Basically, the two most important parts are the local oscillator laser and the sun and the light collection optics that track the sun as a function of the time of day. The signal from the sun and the laser are allowed to interfere, and they produce a signal that we detect with two photodiodes. We take the difference between the two of them and process them using RF electronics. That signal's collected and averaged in a computer to create a spectrum. The signal that we measure is proportional to the sun power, so anything in the atmosphere that absorbs sunlight is going to change the amount of sunlight hitting the detector, and if you tune the laser, you basically end up developing a normal spectrum. The local oscillator is tuned to produce the spectrum, and a leak is then indicated by increased absorption above the expected background, which is about 1.8 parts per million. On this slide, we show a series of spectra that were collected at different pressures, and pressure corresponds to altitude, with the pressure decreasing dramatically as a function of altitude in the atmosphere. And you can see that we start on the right with a single peak at high pressure and low altitude, and that becomes almost completely resolved by the time you get to 1/10 of an atmosphere on the left. And these spectra basically provide basis functions for spectral deconvolution that allows us to determine at what altitude the methane that we're detecting is present at. So we need a way to find the leak. So as I mentioned, the leak is indicated by excess absorption. The direction of the leak is indicated by whatever direction the instrument is pointing towards the sun when we detect that extra methane. And then the spectral line shape basically tells you what altitude that extra methane is at. And then you can do a simple, you know, the elevation angle of the sun as well as the direction, and that simple trig calculation allows you to calculate where the leak is actually located. From an array of instruments, we actually get tomographic information that corroborates that leak location. And as I mentioned, we can cover very large areas with a relatively few number of instruments, say 500 kilometers squared, maybe with 10 small instruments. It's more continuous than satellite coverage, and it has similar sensitivity to the best current satellites, about 200 ppm meters, and I'll show you how we arrive at that on the next slide. So in order to test the sensitivity of the instrument and just show that it's sensitive to excess methane above the background, we inserted a cell of about 5% methane, 10 centimeters long at atmospheric pressure in the instrument path just before the light collection optics. That's 5,000 ppm meters of methane. And you can see on the right a graph of the results, and that's basically the methane mixing ratio versus altitude. Black curve is the background, and then the blue curve is when we insert the methane cell. And as you can see, we detect that methane that's at low altitude on the surface, basically, with a very, very high signal-to-noise ratio. And that means that we can detect very small leaks on the order of 200 ppm meters, just like the satellites. So a couple other things that are important are we get all this information in about 5 seconds. And overall, this is a very, very promising result for developing this novel methane leak detection method. And I think I'll conclude there.